Next thing is to talk about the decisions that the firms will make in this kind of a market. Now, you have no control over the market price, and so what you would do is you would just figure out what is the market price, and then you would figure out, okay, how much should I produce of the good, given what my costs are. Okay, so you're going to choose an optimal quantity. Okay, so they choose an optimal quantity of output, and obviously they're trying to maximize profit. Like any decision that anybody makes, whether you're a buyer or a seller, use marginal analysis. So you think per unit, right? Just like when you're buying, same as when you're selling a good. You think, okay, if I produce a little bit more, how much will I get paid versus what is my cost? As long as what I get paid covers my cost, I will produce it. Right? So they'll look at marginal revenue and marginal costs. Okay, so the optimal amount of any activity is where marginal cost equals marginal benefit. So for a producer in a perfectly competitive market, that marginal revenue, again, is going to be constant, right? Because the price per unit is constant. So each time they sell one motor unit, they get paid exactly the same amount per unit. But marginal costs will always increase, right? We've talked about that in several chapters. When you do more and more of an activity, your marginal costs will rise. So for the producer, what they get paid is constant, but their marginal costs are going to rise. So for the first units, their profit's going to be highest, but then as they produce more and more, the profit per unit will get smaller and smaller. And then that last unit for which they can break even, they'll produce that last unit, but any more than that, then they wouldn't produce it. Okay, so they will produce as long as the marginal revenue covers the cost. And so then what they want to do is they will want to produce all the units for which the marginal revenue is greater than the marginal cost, right up to the point where they break even on the last unit. And then that will maximize their overall profit. On the next page, we have an example. Ted's tailored suits. Okay, so he's making suits We've got the quantity, we've got total revenue, and we've got total cost. All right, so first column is the profit. All right, now, if he's not producing anything, he will lose $240. This is his fixed cost. Right? Remember, that will be the cost that he has to pay even if he's not producing anything. So the fixed cost is $240. All right, if he produces one suit, he will still lose money. One is 50. Okay, two suits. Three suits, 600 minus 390, 210, 280, 310, 300. Okay, so we can already see what quantity will maximize the profit. That will be at 5 here. That will be the maximum profit. Okay, but now we'll look at the marginal analysis. So marginal revenue, the change in total revenue each time he sells one more suit. So the first suit increases his revenue by 200. The second suit increases his revenue by 200, right? 200 to 400. 400 to 600. All right, so the marginal revenue is always $200. That tells us what the price is then. This must mean that the price is $200 per suit. Okay, marginal cost. So now the change in the total cost. So 240 to 250, 10. 250 to 300. 300 to 390. 390 to 520, 130. 520 to 690, it's 170, and 210. Okay. Now, using marginal analysis, Ted will produce suits as long as what he gets paid covers his cost. So definitely the first one, right? The price covers the cost. Second one, price covers the cost. Third one, fourth one, fifth one. But then the last one, cost is bigger than the revenue. So he will definitely not go past this point then, right? He would not produce the last unit because that would make him lose money. Okay, so same conclusion as we got to by looking at the profit. 5 will be the number of suits that he will produce. Okay, last column, average total cost. So remember, that is the total cost divided by the quantity. And we can't do the first one because that's dividing by 0. All right, 250 divided by 1. 300 divided by 2. 390 divided by 3. 520 divided by 4. And that's 138 and 150. Good. Okay. Okay. Now, we can also tell that he will earn a profit because the price, which we've determined is $200, is more than the average total cost. So for sure, he's going to be making a profit. Now, a couple things here, just to review from Chapter 11. So average total cost curves go down and then up. So we have a U-shaped average total cost curve. And the marginal cost goes up through the bottom, right? So there's an equilibrium here between the marginal cost and the average total cost. And so that we can see that here, right? The minimum point for the average total cost is 130. Marginal cost is also 130. So we have an equilibrium here. at 130. But that's not the quantity that he's going to produce. So the price is 200. So I'll just draw a line here at 200. We'll put price equals that. So price equals 200, and then we have an equilibrium. Now it's not quite an equilibrium. It's not quite an equilibrium, right? Because marginal revenue is 200, marginal cost is 170, but it's our closest one, right? It's the last unit for which the marginal revenue will cover the cost. So it's our almost equilibrium, and that will be at the quantity of 5. And at the quantity of 5, the average total cost is 138, which we can see in the diagram would be this point right here. So I'm going to put a straight line over to here. 138, and that is the average total cost. And now we can color in the profit. The profit will be this rectangular area between the price paid and the average cost of 138. So this area here will be the profit. All right, any questions? Okay, so before the midterm in chapter 11, you guys were learning all about the cost curves, many different cost curves. And so the cost curves are important, especially the average total one, because that will show us how much profit the firm is making. But the actual decision about how much to produce always uses marginal analysis. Just like for consumers, our decisions involve marginal analysis. And so the decision about how much to produce is just a comparison of the price to the marginal cost. Okay, so it's just where the price equals the marginal cost. So if the price were higher, then they would produce more. If the price is lower, they would produce less. Okay, so we'll go through lots of examples. All right. Let's see, next page, we have an example about Terry's Toy Trucks. And so this example here is just about the quantity decision. And so for the quantity decision, you just need marginal cost and the price. All right, so marginal cost, so just the change, so 50 to 80, that's a change of 30, 80 to 105. 105 to 125. Okay, good. So marginal costs. Now we did talk about this in chapter 11, how sometimes at the very low levels of output, the marginal cost will go down first, and then the marginal cost will start to rise. So this is an example of a marginal cost curve that has that little dip like that. Okay, now the first question is, if the price is 25, what's the optimal quantity of trucks? All right, so 25, now that's going to have two equilibriums with the MC curve, here and here. So in other words, 25 is about there, so it's crossing the MC curve 2 times. So the first time it crosses at a quantity of 2, and then the second time it crosses at a quantity of 4. Now the producer, in this case, would never choose 2. They would never choose just 2. And the reason why they would never choose just 2 is because they're going to make even more profit on the third unit. because their cost is lower on the third unit, right? The cost is only 20 for the third unit. So they would never stop at just 2. They're going to want to produce the third unit because they're going to make even more profit on that one, and so then therefore they would go right up to 4. Okay, so, all right, so 4. If the price is 40, okay, so that's here. Marginal cost is 40 at 7. And if the price is 50, that's here. Marginal cost is 50 at a quantity of 9. All right, so they will always choose the quantity where price equals MC or MR equals MC. Good. Any questions? All right, so now we'll talk about calculating the profit. All right, so to make a profit, the price has to be more than the average total cost, or the firm's minimum short-run average total cost. We'll be talking about the long run later in the chapter, so not today. We'll talk about that on Wednesday. Okay, so we'll talk about short run and long run. Hopefully you remember from chapter 11. Long run is when you can change all the inputs, including the fixed inputs in the capital. Right? And so then, of course, you're going to make different decisions in the long run compared to the short run. In the short run, it means that you have a fixed input that is fixed. And so your decisions are going to be based more on just your variable costs in the short run, right? Because the fixed cost would be a sunk cost. All right, now to calculate profit, we have 2 equations. So this one, and then with this one here, we can manipulate it a little bit, dividing by Q on both sides. And then total revenue divided by Q is the same as the price. This is the formula for average total cost. And so then we can use this formula as well. And so with this formula, we can see very clearly that as long as the price is greater than your average cost, you'll make a profit. If it's less than your average total cost, then it's negative, so you lose money. And if they're exactly equal, that means that your profit will be 0, and that's called breaking even. All right, so what we're going to do is go through some examples here where the firm has a price that's given by the market, and then we'll figure out what their profit would be. So this example is based on this one from page 6. It's the same set of numbers. It's just that we're only showing some of the numbers. Okay. All right. Now, price is $200. Okay, this is actually the same example as we did before. So first thing, what we want to look for is where is the price equal to the marginal cost? All right, now, we don't have a $200 here, so we don't have an exact equilibrium. So then what we would do is we would pick the last unit for which the price will pay the costs. And so as long as the $200 covers the cost, which is right up to here, they will produce. All right, so they're going to produce 5 units. All right, so quantity is 5. And then at a quantity of 5, the average total cost is 138. And so now what we're going to do is calculate the profit using this formula here. Okay, so price 200 minus average total cost 138 times 5. Good. Next one, the price is 100. Okay, if the price is 100, again, first thing we do is figure out what quantity would they want to produce by comparing this to the marginal cost. And as long as the price covers the cost, they will produce the good. So $100 covers the marginal cost of 10, the next one of 50, and the next one of 90. But then that's it. So this is the last unit here for which the price will cover the cost. So that will be the third unit. And so the quantity is 3. And at that quantity of 3, the average cost is 130. Okay, so now let's use that formula again to calculate the profit. So price 100 minus average total cost 130 times 3. Okay, so they're going to lose money. All right, so now, question here is, why would they produce if they are going to lose money? They've chosen to produce 3 units and they're going to lose $90. Why would they do that? Why would they just not like give up and produce nothing? What would happen if they produced nothing? What's their cost? That's right, which is 240. So what's better, to have a loss of 240 or a loss of 90? Yeah. Okay, so in the short run, because a business has a fixed cost and the fixed cost is a sunk cost, then in the short run, sometimes you end up producing, even if you're going to lose money, just to try to lose less money. Now, obviously, they would not do this in the long run. In the long run, they're going to give up and go do something else. But in the short run, they will produce. It's better to lose $90 than it is to lose the entire amount of the fixed cost. Okay, so why continue producing with a loss? Because if the quantity is 0, then your losing or profit or loss is 240. So Q3 is better because the loss is smaller. All right, so on the next page, we're going to show the same 2 examples on the graph. All right, so first example is when the price is $200. So the price is $200, and then we find this point first, which is the equilibrium, or the closest anyway to the equilibrium, with marginal cost, which was at a quantity of 5. And at the quantity of 5, we had an average total cost here, and then from the table, we figured out that the average total cost was 138. And so then the profit would be this rectangle between the price and the average total cost. Good. Okay. So filling in this part over here, total revenue. So the total revenue that's earned is the price times the quantity. So the price in this case is $200. That's the marginal revenue or the price. So $200 and then the quantity that they're producing is 5. So they will earn a total revenue of $1,000. The total cost, now total cost, you can just look at the table if you want. So total cost at 5 is $690. But we can also calculate it from the graph. The total cost would be the average cost times the quantity. So I'll do that. So ATC times the quantity. So 138 times 5. Oops. Oh, that's 9. 690. Sorry, that's messy. Okay, 690. And so then the profit is 310. Good. Okay. Then the other example was when the price was 100. Again, the first thing that you do is you figure out how much will the firm produce. And they will produce as long as the price they're paid covers the cost, the marginal cost. So they will continue production as long as the price covers their marginal cost, or up to the closest equilibrium, which was at a quantity of 3. But at that point, the average cost was 130. So the average total cost was 130. I'll add that here, 130. And so then they're losing money. So we can color in the rectangle here, but it's a loss of money. All right. So let's fill in the side. Okay, so total revenue, P times Q. So now they're getting paid $100 per unit. And they're making 3 units, so they're earning a total revenue of 300. Their total cost, now again, total cost you could just get from the table. So at 3, the total cost was 390. Or you can multiply the average total cost times the quantity. Okay, and so then, yeah, so then they're going to lose $90. And again, they're going to do that because that's better than quitting. If they just quit, they're going to have a loss of $240. So let's just break out the cost just to show what's happening here. Okay, so the total cost is $390. And that consists of fixed costs and variable costs. So what are those? Right. Fixed costs, we can tell from the table, that's the cost when the quantity is 0. So the fixed cost must be $240. And if the fixed cost is $240, what's the variable cost? The difference, right? $150. All right, so they have made a revenue of $300. That's not enough to cover their total cost. But the revenue of $300 is enough to pay for the variable inputs that they need. After they have paid the variable inputs, so they had 300, they pay 150 for the variable inputs, they'll have 150 left over. That's not enough to cover the full amount of the fixed cost, but it covers some of it. Right? So better to pay off some of it rather than none of it if they just quit and did nothing. Good. Okay. Any questions? Okay. Okay. So let me just sort of summarize what's going on here. Now, for all firms, they will have the U-shaped average total cost curve, just like you learned in chapter 11. They have a marginal cost curve that goes up through the bottom. Marginal cost. In a perfectly competitive market, the price is out of their control, right? The price is out of their control. So they just have to take the market prices given and do the best they can. Okay, if the price is high, like above the average total cost, they'll make a profit. So let's say P1 is here. Now they will choose to produce the quantity where that price equals their marginal cost. So I'll put Q1. And then in this case, that price is more than what the average cost would be. Right, here's the price, here's the average cost. So they would make a profit, and so that is wonderful for them. If the price were lower, let's say P2, looks like they're still going to make a profit. Now the quantity they would produce is smaller though, right? Where this price equals MC, that's at a smaller quantity. But that price is still above the average cost at that point, so they would still make a profit. Not as much, right? Bigger profit here, smaller profit here, but they would still make a profit. If the price is somewhere below the average cost curve, clumsy today, then, okay, so first that equals MC here, so of course they're producing a much smaller quantity. And because that price is less than the average cost, they're going to lose money. So they would lose money. Last option, what if the price is here? Yep, the price for P4, that would equal MC here. Would they earn a profit or lose money? Or neither? Here's the price. Where's the average cost? Same point, right? Yeah, so at this price, the producer chooses a point where price equals MC, but the MC and the price are also equal to the ATC at that point. So they would break even at that point. All right, so regardless of the price, the producer chooses to produce the quantity where the price equals MC. So obviously at higher prices, that will be at a larger quantity. At lower prices, that will be at a smaller quantity. What determines whether they make a profit or not is just, is the price more than their average cost, less than their average cost, or exactly equal to their average cost? Good. All right.